Okay, so today we're going to talk about properties of parallel lines. So if you think about the angle pairs that we talked about on yesterday, we talked about corresponding angles, we talked about alternate interior angles, same side interior angles, and alternate exterior angles. Well, it turns out that while those particular angle pairs didn't have any special properties yesterday because the line pair was not parallel, when the line pair is parallel, they actually do have special properties. So when the line pair is parallel, it means that the corresponding angles will be congruent. The alternate interior angles will also be congruent. The alternate exterior angles will be congruent. However, the same side interior angles will not be congruent, but they will be supplementary. Okay? Now, how do I know if the line pair is parallel? Well, it should not be a mystery. You should be able to tell in the directions or in the diagram, one or the other. For instance, if I draw this particular line pair, and we're going to call these lines A and B, and then I cut them with a transversal, which we can call line T, okay? In the directions, it would read something like A is parallel to B, okay? However, if it doesn't read A is parallel to B, then you will be able to tell that A is parallel to B based on the diagram. The diagram will have little arrows like this going in the same direction on both lines, and that would signify that A and B are parallel. Okay, so either or you'll see. When we have these parallel lines, we create congruent pairs. All of the corresponding angles will be congruent. Okay? All of the alternate interior angles will be congruent. So that would be this one, right? And this one would be congruent. All of the alternate exterior angles would be congruent, which would include this one and alternate exterior, this one. Okay, the same side interior, which would be this angle and this angle, would be not congruent but supplementary. Okay, all of this is true if and only if the line pair, line A and B, are parallel. So if we look at our diagram here, at the bottom it asks us, according to theorem 3.2, angle 3 is congruent to what other angle? Well, let's look up here at theorem 3.2. Okay, theorem 3.2 is our corresponding angle theorem, and 3.2 suggests that if the lines are parallel, then corresponding angles are congruent. So if I look at my diagram right here, are the lines parallel? Both R and S are parallel. So angle 3 is right here. What is a corresponding angle to angle 3 that would be congruent to angle 3 based on that theorem 3-2? It would be angle 1. Very good. Because angle 1 is in the same location on a different intersection. Notice that angle 3 is in the bottom left position of this top intersection. So when we get to the bottom intersection, in order to find a corresponding angle, we're looking for the angle that is also in the bottom left position. Okay? Let's look now at theorem 3-1. 3-1 is the alternate interior angle theorem, and that states that if the two lines are parallel, that the alternate interior angles will be congruent. So again, we're looking at angle 3. What would be an alternate interior angle to angle 3? Angle 7. Alternate means opposite sides of the transversal, right? And interior meaning inside of the line pair. Why would 3 and 6 not be alternate interior angles? They are adjacent, right? And alternate interior angles are non-adjacent. What kind of angle pair would 3 and 6 actually make? They would be supplementary because they are what? They are a linear pair, right? Because they are adjacent angles on the same line. Do you see that? Which would make them, you guys are correct, supplementary. Okay? The last question asks us to look at Theorem 3.3. Theorem 3.3 is alternate exterior angles. This is going to be on opposite sides of the transversal and outside of the linear pair. Okay, if we look at angle 1, which is in this bottom left position, what would be an alternate exterior angle to angle 1? Angle 5 is correct. Okay, angle 1 and angle 5 will be congruent based on Theorem 3.3, which states that if the lines are parallel, the alternate exterior angles will be congruent. The next thing that we need to look at is how can we use this particular concept, these angle pairs, to find missing angles. And so we're going to use this trapezoid pictured here to find missing angles. The first thing that we need to talk about is the bases of the trapezoid, because remember we have base 1 and base 2 for the trapezoid. So if we look at base 1 and base 2 for the trapezoid, we notice that we have two parallel lines. Does everyone see that? A parallel line here and a parallel line here. Notice that arrow that I was talking about that signifies the parallel line, right? So instead of it telling us that these two lines are parallel, it's showing it to us through the diagram, okay? So the first question is, the bases of the trapezoid are parallel or perpendicular? Parallel, good. So if I look at these two parallel lines, I'm going to treat the sides as if they are the transversal, okay? So if these sides are the transversal, what is the relationship between these two angles that are between the parallel lines and next to the transversal? What would be their relationship? Would they be corresponding, alternate interior, alternate exterior, or same side interior? Would they be corresponding, alternate interior, alternate exterior, or same side interior? They are going to be same side interior angles, okay? What do I know about same side interior angles? Are they congruent or supplementary? They are supplementary. So I can take these two expressions, add them together, and their sum should be what? 180. So I can add 2x plus x minus 12 equals 180. That will give me 3x minus 12 equals 180. If I add 12, I'll get 3x equals 192. Divide by 3 and I'll get x equals what? 64. Okay? Then on this other side, I can do the same thing. These are also going to be same side, right? So 3y plus y plus 20 equals 180, which gives me 4y plus 20 equals 180. If I subtract 20, I'll get 4y equals what? 160. Divide by 4, and y will equal what? 40. Yeah? Now, sometimes it's very difficult for us to see the transversal and the parallel lines. What I suggest that you do if you have this situation is that you actually extend the lines so that you can see what's really going on. If I extend these lines beyond, and then I actually cut them with a transversal line, and I'll do the transversal line this way. Can you actually see the same side interior relationship now? Okay, so oftentimes when you have a figure, it's difficult to see. If you'll just extend the lines beyond the actual closed polygon or closed figure, you'll be able to better see the relationship. Okay, so for the next few minutes, what I'd like for you guys to do is go ahead and work on the practice problems for this section. You're going to do 7 through 10 and then 12 through 20. Okay, and they can be found on page 153 and 154 if it's not clear enough on your Xerox copy. Okay, there's only one proof that you'll work through, and it is a guided proof, and it's number 10. We will not be doing number 11, so you can skip number 11. Okay, and let me know if you have any questions.